Flash point is one of the important indicators in oil product testing and analysis. Today we will learn about the determination of oil flash point on the 25th of February 2005 fishing boats docked at Bian Wharf in Beihai City. Guangxi experienced cabin vapor explosions after refueling with diesel while starting their main engines. The accident resulted in 4 severe injuries and economic losses of approximately 600,000 yuan. According to the Oil Quality Inspection Report issued by the Beihai Product Quality Inspection Institute, the diesel purchased for the 2 boats failed to meet standards in 4 out of 5 key parameters, including pour point, flash point, water content, mechanical impurities, and distillation range, with only water content meeting the requirements. Particularly, 3 critical parameters, pour point, flash point, and distillation range, were severely out of specification. According to technical requirements, the flash point of number 0 diesel should be greater than or equal to 55 degrees Celsius. However, the flash point of the diesel purchased for the 2 boats was only 15 degrees Celsius. Therefore, the determination of oil flash point is crucial for vehicles, ships, and other equipment. So how is the flash point of oil determined? Today, we will learn about the determination of flash point in a closed cup. The determination of flash point in a closed cup is conducted according to the recommended national standard GBP 261/2008. Determination of flash point Penske-Martin's closed cup method. It is applicable to the determination of flash points above 40 degrees Celsius for flammable liquids. Taking diesel as an example, the national VI standard requires that the flash point of ordinary diesel, depending on the grade, should be controlled no lower than 60 degrees Celsius and 45 degrees Celsius, while automotive diesel should be controlled no lower than 60 degrees Celsius, 50 degrees Celsius, and 45 degrees Celsius, respectively. During the experiment, we will use a closed flash point tester, thermometer, barometer, heating bath, and cleaning solvent. The cleaning solvent is used to remove small amounts of sample residue adhering to the test cup and its lid. The choice of cleaning solvent should depend on the viscosity of the sample and its residues. Low volatility aromatic hydrocarbon solvents without benzene can be used to remove oil traces. Mixed solvents such as toluene, acetone, and methanol can effectively remove gum-like deposits. Next, let's learn the steps for determining flash point. First, instrument preparation, placement of the instrument. The instrument should be placed in a room without air currents and on a stable tabletop. If air currents cannot be avoided, use protective screens around the instrument. If the sample produces toxic vapors, place the instrument in a fume hood with independently controllable airflow adjusted to draw away vapors without affecting the vapor space above the test cup. Second, cleaning the test cup. First, rinse the test cup, lid, and other accessories with cleaning solvent to remove any gum or residue from previous experiments. Then, dry them with clean air to ensure all solvent is removed. Third, assembling the instrument. Check the test cup, lid, and accessories to ensure they are undamaged and free of sample deposits. Finally, assemble the instrument properly. Sample preparation. Place the sample in a suitable sealed container. For safety, fill the container only to 85 to 95% of its capacity. Store the sample under appropriate conditions to minimize evaporation, loss, and pressure buildup. The storage temperature should not exceed 30 degrees Celsius. Subsample at least 28 degrees Celsius below the expected flash point. If the subsample is stored before testing, ensure the container is filled to more than 50% of its capacity. If the sample contains undissolved water, separate the water before mixing the sample, as water can affect flash point determination. However, in some residual fuel oils and lubricating oils, water may not be easily separated. In such cases, use physical methods to remove water before mixing. Note, gently shake the sample to mix it before sampling and handle it carefully to avoid loss of volatile components. Then proceed with the experimental steps. Third, flash point determination. Observe the barometer and record the ambient atmospheric pressure near the instrument during the experiment. Although some barometers automatically correct, this standard does not require correction for atmospheric pressure below 0 degrees Celsius. Pour the sample into the test cup up to the circular mark. Cover the test cup lid and place it into the heating chamber. Ensure the test cup is properly positioned, then lock the device after connecting. Insert the thermometer, ignite the test flame, and adjust the flame diameter to 3 to 4 millimeters. Or turn on the igniter and adjust its intensity according to the instrument manual. During the entire experiment, heat the sample at a rate of 5 to 6 degrees Celsius per minute with a stirring speed of 90 to 120 revolutions per minute. When the expected flash point of the sample is not higher than 110 degrees Celsius, start ignition at 23 degrees Celsius below the expected flash point. Ignite once for every 1 degree Celsius increase in temperature. Stop stirring during ignition. Use the slide operation button on the test cup lid or the ignition device to lower the flame into the vapor space of the test cup within 0.5 seconds. Hold it in place for 1 second, then quickly raise it back to its original position. Note if the expected flash point of the sample is higher than 110 degrees Celsius. Start ignition at 23 degrees Celsius below the expected flash point and ignite once for every 2 degrees Celsius increase in temperature. Record the temperature at which the flame causes distinct ignition in the test cup as the observed flash point of the experiment. Do not confuse the pale blue halo around the test flame before the actual flash point is reached with the true flash point. If the difference between the recorded observed flash point and the initial ignition temperature is less than 18 degrees Celsius or greater than 28 degrees Celsius, the result is considered invalid. Replace the sample and repeat the experiment, adjusting the initial ignition temperature until a valid measurement is obtained. That is, the difference between the observed flash point and the initial ignition temperature should be within 18 to 28 degrees Celsius. Main factors affecting closed cup flash point determination include sample water content, heating rate, ignition control, sample volume, and atmospheric pressure. First, sample water content. If the sample contains undissolved water, it must be dehydrated. Otherwise, when heated, the dispersed water in the oil will vaporize, sometimes forming bubbles covering the liquid surface, affecting normal vaporization of the oil, delaying flash ignition, and leading to higher results. Second, sample volume. The sample must be filled to the circular mark. Excess sample will result in lower flash point values, while insufficient sample will result in higher values. Third, heating rate. The heating rate must be strictly controlled according to the standard. If the heating rate is too fast, the sample evaporates rapidly, causing the local concentration of the mixture to reach the lower explosive limit prematurely, leading to early flash ignition and lower results. If the heating rate is too slow, the test duration prolongs, ignition frequency increases, and some oil vapor is consumed, raising the temperature required to reach the explosive limit, resulting in higher values. Fourth, ignition control. The size of the ignition flame, its distance from the liquid surface, and the duration of exposure must comply with standard specifications. A larger spherical flame diameter, closer proximity to the liquid surface, or prolonged exposure time will result in lower values, while the opposite will yield higher values. Fifth, lid opening time. The lid opening time must be controlled to 1 second. It cannot be too long, otherwise the result will be higher. Sixth, atmospheric pressure. The flash point of oil is related to external pressure. Lower pressure facilitates oil volatilization, lowering the flash point, while higher pressure raises it. Record the experimental data and perform calculations and processing. The standard specifies 101.3 kPa is the baseline pressure for flash point determination. If there is a deviation, apply pressure correction and report the result as an integer. This formula provides precise correction within the atmospheric pressure range of 98.0 to 104.7 kPa. It may also be used outside this range. Students, please consider: how should the temperature rise be controlled during closed cup flash point determination? Why is it necessary to correct the measured flash point value? In this section, we mainly explained the method for determining oil flash point, the steps for flash point determination, and precautions. Additionally, we learned about data processing and calculations. That concludes today's content. Goodbye, students.